Hi guys, and welcome to a brand new section of videos relating to all the fun stuff, binomial and quadratics and all sorts of stuff. Part of the Year 9 course over here in Australia, but basically used throughout the world. Don't worry if you're not in Year 9, it's all good. It's dealing with expanding binomial products. My name is Darren from Maths Guru. You're going to say, what on earth is Maths Guru? It's my little world, my little place on the internet where all these videos and downloadable notes and all sorts of exciting stuff can be found. Absolutely head over there if you can. Now, one of the things I asked you to do before I get into this is to subscribe to my YouTube channel. Turn off notifications if you don't want to be spammed, but by clicking that subscribe button, obviously YouTube just lets me know that someone out there has watched a video or someone out there actually has watched some other work that I've done. Nobody watches maths videos except my mother, and I don't think she can actually create any more accounts to follow me. So if you can actually just subscribe, that would be absolutely great. Now, what am I going to do? Well, normally I'd go through the learning objectives, but there's not a lot here to go through. But it should build on maybe a little bit of what you've done before, maybe not. It doesn't matter. I'm going to see you through it. If you want to pause the video at any time and read over what's going on. Right, a recap of past learning. Now, in previous parts of the world or the school or the year you've been doing, you may know that we can expand brackets, right? So if we had 4 brackets of x plus 6, we know that everything outside the bracket must multiply by everything inside the bracket. So we may say, well, the 4 times the x and then 4 times plus 6. And you'll notice I always say plus 6. It becomes important a little bit later on. Now, if I was going to multiply that out or, expand the brackets, well, 4 times x is 4x and 4 times plus 6 will give me plus 24. And I've expanded a set of brackets. Brilliant. And the idea is that effectively what you do there works for pretty much everything we do. But what happens if we get something really complicated? Well, what's a binomial product? And I can't help myself. Do you see him over there, that little gnome? Yeah, anyway. He's a binomial product. Still sad joke? I thought so too. The dad jokes don't get any better. But bi means 2. Gnome has nothing to do with it whatsoever. And product means time. So we're timesing 2 things together. And so binomial products in the context that we're going to do now might be something like this. We might have 2 sets of brackets. There's one and there's another, which are multiplied together. So in that situation, they are binomial products. There are 2 things multiplied together. Now, you've not seen anything like that before. I don't think you have, but that's okay. I'm going to show you how we actually expand them together. But before we go any further, I want to go back to junior school. Now, what I want you to do is have a go at the question behind me. Yes, come on, have a go at the question behind me. Pause the video. It's a bit of a trick, but I want to see what you do. All right, I'm not going to see what you're doing, but anyway, I'll pause the video and I'm just going to pause for a second. Now, if you pause the video, is this the way you did it? 23 times 12. I've got to write them underneath each other. I've got to do that random line there. Right, 2 times 3 is 6, and 2 times 2 is 4. Basic times tables. Oh, hold on a moment. I've now got to put a 0 in there. Why have you put the 0 in there? Anyway, whole new discussion. I do 1 times 3 is 3. 1 times 2 is 2. Then for some random reason, we add those together, and 6 times 0 is 6, and 4 times 3 is 7, and the 2, and that gives me 276. Now, if you've done it that way, and you're like, well, I've done it that way, what you've just done is a construct. What you've just done is followed an algorithm. Because so many teachers out there teach this, it's not actually in the Australian study design. Nowhere in the lower school does it say anywhere in a book that that is the way to teach it. It's just that that's how teachers have always been taught at school, and it just continues. There are better ways of doing it. And this whole putting a 0 in here confuses people left, right, and center. Not the strong mathematicians, but lots of people just because they don't understand why it works. They don't understand. They're just trying to follow a rule, a recipe. And again, why do we add these together? Why do I do the 2 times 3 first? Why didn't I do the 1 times the 3 first? Right? So all of this is really, really confusing, but there is another way of doing it. Right. I want to think of the number 23 as equal to 20 plus 3. And I want to think of the number 12 as 10 plus 2. What I'm now going to do is I'm going to write them out like this. I'm going to draw a grid. I'm going to put a times down. I'm going to put 20, 3, 10, and 2. So I'm basically doing 23 times 12, but in a different way. I've just split them up into 20 plus 3 and 10 times 2. Right, well that's okay, because what goes in here is nice and easy now, because it's 20 times 10. So what is that going to be? 200. And what goes in this box is 3 times 10. So that box there is 3 times 10, 30. This box here is 20 times 2, which is 40. And this box here is 3 times 2. Basically, I'm doing row times column, and where they intersect, that's where I do my answer. So 3 times 2 in that situation is 6. And now, believe it or not, all I actually have to do is add all of those individual values together. So 230, 270, and that becomes 276. To me, nice and quick and easy, right? Now you're going to try and say it felt like a long time. That's because most of what I do feels like it takes a long time. But the reason we like this, or the reason that we should be teaching everyone in junior school to do it this way rather than that stupid put a 0 in the way, is because then when we get to binomial products, which we're about to get onto, life becomes easy. Because what I'm really doing here, when I'm doing 23 times 12, is I'm doing 20 plus 3 times 10 plus 2. They're just split up in a slightly different way. 23, 20 plus 3, 12, 10 plus 2, and I'm timesing them together. But look what happened. We did 20 times 10. That gave me one of the answers. We did this 20 times 10. We did 10 times 3. 10 times 3. We did 20 times 2 and 3 times 2. Now, what we've actually done is we've multiplied everything in this bracket by everything in that bracket. And so, if we use the basic idea then, that basically now if we had x plus 3 multiplied by x minus 2, well, this looks very similar to 20 plus 3 times 10 plus 2, yes? And what did we do? Well, because we had two things that were added together in the brackets and two things that are added in the brackets, we could create that grid. Well, so can I create the grid to do this x plus 3, x minus 2? Absolutely. I can split this into x plus 3 and x minus 2 there. All right, we can copy that minus sign in. And now, expanding these brackets, all right, is just a case of what goes in this box here. Well, that's x times x. And we know that x times x is x squared. What goes in this box here? Well, it must be that row and that column. So it's x times plus 3, which is plus 3x. And you'll notice I will always say the plus 3 because it makes life easier. What is going to go in this box here? Well, it's that row times that column. So x times minus 2 or minus 2x. We normally write the numbers first. And then finally, what goes in here and here? Well, plus 3 times minus 2. Well, a positive and a negative makes a negative. And 3 times 2 becomes 6. All right, so what do we do now? Well, we just write them all out. So that becomes x squared plus 3x minus 2x minus 6. And all I've done is I'm reading top to bottom, left to right, because that's what we do in real life, isn't it? Top to bottom, left to right. Oh, now all we have to do next, and I know I'm doing an example, but I'm trying to show you the stages that we work through. Now what we do is we collect like terms. Are there any other square numbers? All right, x squared in there? No, so that stays x squared. I've got a plus 3x minus 2x. Oh, I've got 3 xylophones and I'm taking 2 xylophones away. I've just got 1 xylophone left. So that becomes plus x. And I'm left with this minus 6 on the end because there's no other numbers that I can add it. And believe it or not, by writing this in another way and then out that way, I have finally expanded a binomial product. So the whole purpose of what I'm about to show you over and over again is how to turn a binomial product into expanded form. All right, and again, the questions might use the words expanded form and whatever. Now, there is another way of doing this, and I will show you because this is the way I was taught it at school. So we had x plus 3, for example, and x minus 2. What I was taught at school was FOIL, and that stands for first. So basically multiply the first two together, then the inside pair, the outside pair, and the last pair. And you're going to say, what on earth does that mean? Well, it says multiply the first in each bracket together, multiply the inside together, multiply the outside together, and multiply the last together. All right? So basically, it's saying multiply everything by everything. Really? Yes? So if I was to do that, x times x would give me x squared. 3 times x, or plus 3 times x would give me plus 3x. What did it say? Outside, plus 3 times minus 2 would give me minus 6. And then the outside would have been x times minus 2. So let's do that one. That would have been minus 2x, he says. And then the last two terms would be plus 3 times minus 2, which is minus 6. And lo and behold, it's exactly the same thing. Now, the reason I don't like doing that really is because my positives and negatives, if I forget a positive and negative, it all goes horribly wrong. I like the grid method. I don't think it takes too long to draw that grid out. All right, so again, if I was to simplify this, I'd have x squared plus x minus 6. Ka-ching! All right, so again, it all comes down to like terms. And just to recap what a like term is, just for you to remember, anything with the same letter in it can have a different different coefficient, same letter, basically are like terms. So in this situation, I can do 4x plus 7x minus 2x minus plus 10x, for example, because they're all x terms. However, that x squared term, there is nothing else in here with a floaty to x2, or an x with a floaty 2. Is there anything else with just an x in it? No. Anything else with a minus 2x cubed? No. Any other numbers? No. So again, this comes back down and becomes really important when we're expanding brackets. So here's some examples. All right, expand the following. We can use FOIL if you want to. We can use the grid method as well. So I'm going to do the grid method for x plus 3 and x plus 5. So again, this now is going to be given. That one's going to give me x times x, which is x squared, plus 3 times x is plus 3x, plus 5x is plus 5 times x is that, and that will give me plus 15. Again, all I'm doing is multiplying things together. Right, having done that, I now do the difficult job of writing it all out. So I get x squared plus 3x plus 5x plus 15. I'm now going to collect like terms. Are there any other x squared terms? No. I have some x terms that are the same, so those I'm going to collect. So the x squared stays there. Plus 3x plus 5x is plus 8x plus 15. And there we go. Ka-ching, I've expanded that. What about the next one? I'll do the next one as well. So let's see, what have we got? We've got a quick grid, and we've got x minus 4, x plus 7. So in this situation, I'm going to do x times x, which is x squared. X times minus 4 is minus 4x. Plus 7 times x is plus 7x. And if you notice, basically, in this situation, I'm just putting those two together, and I'm putting those two together and putting them each of the boxes. So not a lot of brain power there. The most complicated one is minus 4 times plus 7, which is hopefully minus 28. Right, what do? We write them all out. And again, you might turn around and say, well, I don't need to write them all out, do I? Because I can probably realize now that I've just got to do the minus 4x plus the 7x. They are the only like terms in that. So that gives me x squared. Minus 4x plus 7x is plus 3x, minus 28. Now, if I'm going too fast for you, don't worry about it. You can have a go again, right? Just stop the video, go back, do it the long way. Make sure that I'm actually not making silly mistakes. Let's move on to the next couple, right? They're getting a little bit tricky. Yeah? What we notice now is they're trying to trick us with this 2x business, right? So again, let's draw my grid. What have I got now? I've got 2x minus 1, x minus 6. Right, now again, don't get tricked. I've got 2x times x. So that becomes 2x squared. Minus 1 times x just becomes minus 1x. Now we don't get tricked. Minus 6 times 2x. We've got to multiply those 2 and 6 together. So that becomes minus 12x. And minus 1 times minus 6 becomes plus 6. And again, the only things I need to worry about adding together will be those. So what do I have? 2x squared. I've got a minus x minus another 12x. That's minus 13x. And again, I've seen the people who make these, who go wrong with these questions is basically the ones who just don't know their times tables or the negative numbers, all right? And then what have I got? Plus 6. All right, ka-ching. And again, stop the video, have a go, see if you can beat me to it. Not a competition. Oh, it is a competition. Okay. So what do we got here? We've got 5x minus 2, 3x plus 7. Oh, what we notice now is they're trying to trick us. I've got numbers on both of the x terms, but it doesn't trick me if I know my times tables. So I've got 5x times 3x. So 5 times 3 is 15. X times x is x squared. I've got minus 2 times 3x. That's minus 6x. I have plus 7 times 5x is plus 35x. And minus 2 times 7 is minus 14. And again, all I really need to worry about now is those two added together. So the 15x squared stays where it is. Minus 6 plus 35 is plus 29x. And I'm going to do minus 14. All right, see? And again, I don't think there's anything more complicated than this if you do it using the grid. Now, maths is a huge trick, and we can actually take numbers out of this altogether, but it doesn't change the rules. The question is, do I have a bracket times a bracket? I do. So these are binomial products, in which case all I'm going to do is I'm going to draw a grid, and I'm going to put A plus B, C plus D. All right, so multiply these together. What is A times C? Well, when I went to school, and I'm still at school, so depressing, it's AC. What's plus B times C? Plus BC. What is A times plus D? Plus AD. Plus B times plus D will be plus BD. Now, the trick to the question here is BC and AD, are they like terms? No. So actually in this situation, I can't add them together, but I can just write it now as AC plus BC plus AD plus BD. And lo and behold, that was the trick. The trick was that your brain wanted to do it another way, but you just go back to basics. Deal with what you need to deal with. Draw the grid. Can we do it backwards? Later on in the year, I will be showing you how to do it backwards, or later on in this course. It is actually really, really important in maths to go from that back to that. All right, so what we call this thing here, anything with an x squared term is not linear. That there is called a parabola or a quadratic. And it is absolutely massively necessary to be able to turn something like, I put the bracket around, into a binomial product, because that binomial product actually is giving us a lot of secret information. All right, but we'll just work it out a little bit later on. Now, obviously, what we do need to understand is how to do things backwards. And what do we now notice? Well, they're missing a bracket here, or they're missing a value here. So what I'm actually going to do is I'm going to draw my grid, because they've actually given me some important information. So I know that I've got x plus 2 here, and I've got an x plus something here. I don't know what that one is. And what have they told me? Well, they've told me that I've got an x squared. Well, we know that that first term always comes from in here. And I know that I've got this plus 6, and where does that last term always come from? It always comes from here. Ah, well, in that case, this is awesome, because I now know that plus 2 times something gives me plus something, and in which case that there must be plus 3. So just by writing the grid out, I now know I can write that as 3. But should we just check? If that's 3, this should be 3x. That should be plus 2x, so plus 3x. And shall we just check, is the plus 2x and the plus 3x plus 5x? Yes. So the middle term here basically comes from those two added together. So the first term always comes from here, the second term always from here, and the middle term is always from those two added together. Why might that be useful? Well, let's look at this one here. Does the grid method work? Let's see. I've got an x plus 1. I've got, I don't know what that is, and I've got a plus 3. And what information do they give me? Well, they're only giving me the first term. So I know that that there has to be 2x squared. This is almost like Sudoku, really, isn't it? So can I find this value here now? Well, I should, Coco, because I know that this is created by that times that. So this here must be 2x. Can I now find my missing values? Absolutely, because I'm now going to fill in the rest of my table. So 2x times plus 1 is plus 2x. X times plus 3 is plus 3x. Plus 1 times plus 3 is plus 3. And now I'm just going to simplify it, because that's going to give me 2x squared. Let's add the plus 2x and the plus 3x, which is going to give me plus 5x. and plus 3. I love this grid method. And believe it or not, that's the end of the video. Thank you very much for watching. Hopefully it's been helpful. Practice really does make perfect. They say if you do 20 questions and practice it over and over again, then it goes from short-term memory into long-term memory and you will be a genius. There are other videos in this series coming. My name's Darren from Maths Guru. Please head to YouTube and subscribe if you would do the honor for me. Again, it means the world to me. There are other videos. I keep saying that. Hopefully I'll see you in one of those. If not, please take care and stay safe. Bye-bye.